This is Annette Kirkland, and welcome to Beyond the Gates. This season, we're going to be highlighting ERDC's legacy of groundbreaking research and cutting-edge technologies. Join us as we explore how innovation continues to drive progress in military and civil works missions. And I have with me Dr. Carol Johnson. She is a research civil engineer with the Geotechnical and Structures Laboratory, and we're going to be talking about one-of-a-kind blast technology at ERDC. Good morning, Dr. Johnson.
Good morning.
How are you this morning?
Doing very well, thank you.
We got fall in the air.
We do.
What does fall mean?
For us, football.
Football, that's right. You know, you have LSU, I have Ole Miss. You know, it's a thing.
It is a thing.
We can be friends right now.
Very much so.
We can be friends right now. You know, in a few weeks, I don't know. But anyway, I'm just kidding. But we have some very, wow, subject to talk about today. But the first question today is, tell me about yourself and your background.
Well, I am from Benton, Louisiana. It's a very small town in North Louisiana. I attended Centenary College and received a bachelor's in math with a minor in physics. From there, I went to LSU and completed a bachelor's in civil engineering and a master's, emphasis on structures. Went to work for Shell Oil Company installing oil rigs in the Gulf of Mexico for a little while.
Okay.
Heard about ERDC, decided that I would come up for an interview, and that was 25 years ago. And so ERDC sent me to get a PhD at Texas A&M University. And
Okay.
so now I am not only an LSU Tiger, but now I'm also a Texas A&M Aggie.
You're an Aggie.
I am.
So that is, I did not know all this about you. So what is your role at ERDC?
Well, I am in charge of the blast load simulator. It's a facility that allows us to do research regarding explosive events against structures or personnel and look at how we can better protect them. And so as a research civil engineer for them, I will design and execute the experiments and then take that data and transition it to our different numerical modelers that we have on site there at ERDC. But I think I have the best part of the job because I get to push the button and make it go boom.
I've been there.
Yeah.
I didn't push the button, but I have been there and seen the whole, I guess you call the build up to it. It's pretty exciting.
It's a lot of work, and then it's over in a couple of milliseconds.
It is milliseconds, isn't it? And so you've been doing that for 25 years.
Yes, I have.
Okay, great. So we are celebrating the 25th anniversary of West becoming one ERDC, and with the collaboration of all the labs together. What, in your role at ERDC, do you work with the other laboratories?
We do. We're actually working with the Construction Engineering Research Lab, CERL, in Champaign, Illinois, testing on 3D printed concrete. So we are evaluating those types of construction techniques using a basic material, concrete, and how well it can perform against blast effects or the pressures associated with a different blast event. And so that started out with a little small 4 foot by 4 foot target, and now we're shooting a 7 foot by 7 foot target. So again, we're starting small where it's more economical and moving up to becoming more efficient. So we're able to conduct experiments to determine what the capacity of those are and how we can improve the shape, because you can, in 3D printing, you can print different shapes. It doesn't have to be your traditional flat wall. Now we can do different things. And where it's important for us is Construction Engineering Research Lab, they're looking at the techniques and the processes, but we have more experience on the blast side. And so, but maybe not so in the actual construction techniques, because the last time I poured concrete was probably in the backyard. It was not at ERDC. And so ERDC is a big team, and it's very important. We have those folks that are experts at pouring concrete and mixing concrete, and then we have our welders that come in and build our test frames, and our electricians that come in and make sure everything is running well. And so it's a big collaborative effort. So each person has their own little piece of the pie there, so to speak, or the puzzle. And once that puzzle is completed, that's when we're able to do the test. But not everybody gets to see the final results from the test, but they have to know that they're all very important to the process.
Right. There's just, as you say, there's so many professional people that come together, and if you want to be an engineer or even different roles other than engineers that come into play with what you do.
Yes, I mean, think about the electricians, the welders.
Right.
Maybe the university atmosphere wasn't for you, but maybe you're a great welder. Well, there may be a spot for you there.
Right.
Or computer scientists, very important also. They're the numerical modelers. You have to have a team that's very diverse and able to get to the most efficient and successful end product.
So what is the Advanced Blast Load Simulator, and how does it work?
That is our newest addition, is actually the Advanced Blast Load Simulator. The original Blast Load Simulator is a compressed, gas-driven, basically shock tube that we generate a blast load, a very dynamic load. We've used it for roughly 20 years doing different types of blast effects research. We just added the Advanced Blast Load Simulator, which is a combustible gas-driven, so we actually have a fireball that's going to be created with the new device, but it's all underground, enclosed in a...
Can it be watched?
Yes.
Oh, okay.
Yes, we have high-speed cameras set up
cool.
and normal speed cameras, and so you'll get to see the event, and then also the results from the target that we're going to shoot. And this new one is much bigger than our original. The original one has a target space of roughly 71 inches by 53, so very small scale, so we had to scale all our targets down. The new one is 14 foot by 14 foot, so now we are doing full-scale experiments with no more questions about scaling factors or things of that nature.
Right.
So it allows us to expand our knowledge base and remove some of those questions.
Okay. So how is the ABLS used, and what kind of research is conducted with this technology?
Well, you usually hear us talking about reflected pressures. That would be your test against a wall, window, or door. Or diffraction or engulfment experiments, we would look at how the blast pressure propagates around a target. So say a mannequin, if we're going to look at personal vulnerability or traumatic brain injury. So the particular device has to be able to do small pressure loads, because it only takes roughly 3 psi to have a traumatic brain injury, all the way up to a hardened structure, which is you're testing around 100 psi reflected pressure. So that's a very wide performance envelope that a experimental device has to be able to accommodate. And so what we're looking at is how to better protect our troops and our citizens here at home.
Right.
Because with the new, well, not necessarily new, but with the increased threats that we have, we do need to be able to retrofit and strengthen our facilities here in the U.S. and overseas.
So important. So important. So when people call our office and go, what's that boom? Is that what they're hearing, or is that something else that they're hearing?
I think that is going to be something else.
Okay.
We may make a little bit of noise.
Right.
But, we also have a high explosive field site close by.
Right.
And that may be what they're hearing during the summertime.
Right. I know I think there's going to be a test, and we had got a connection about a test coming up either this week or next. I think it's next week. But anyway, I didn't know if anybody can feel when you do those testings.
We haven't had any complaints.
Okay.
So, I'm gonna
Not
leave it
that
at
you're aware. Okay.
That I'm aware of.
Okay, good. So what are the benefits of using the ABLS as opposed to going out and conducting full-scale explosive experiments in the field?
It's a much more efficient process to be able to do it here in Vicksburg, Mississippi. We do not have to send our team out to a remote field site and be housed in a hotel room. So it's very economical in that sense,
right.
in that we can be here at home, and we can come in and we can do our test and turn that research over very quickly. The second thing is if you've been out to a high explosive field site and you go out there on shot day and it rains, well, you get to go spend the next couple of days at the hotel room until your next shot day comes up.
This is true.
So here at ERDC, with the blast load simulator, we shoot every day. It doesn't matter if it's raining. We're inside the underground enclosure. Basically, the only days that we don't shoot is when there's ice or snow on the ground and ERDC shuts down.
I was about to say, why does that keep it? But again, nobody's there. So that makes sense. So I understand that recently there was some major upgrades to the ABLS. Can you tell us about those improvements and why they were important?
We did. First off, again, is the scaling factor. To be able to test full-scale targets is very important, and we're increasing that performance envelope so that we can go from the 3 to the 100 psi. And now we are creating that fireball, so you get a little bit of the heat factor that's associated with the explosive event that we did not get when we were doing the compressed gas driven test or experiments. And so taking out that guesswork on the scaling factors is very important. And also it allows us to do more tests in the facility than out in the field. So what we consider it as a tool in your tool bag, so to speak.
Right.
It's not your final test for your target, but it allows you to do a lot of your parametric research where you're looking at 30 different concrete designs, for example, and you want to finally test your full scale. You don't want to take all 30 samples or build 30 different buildings. You can do small samples, meaning 12 foot by 12 foot, here at the BLS, and down select those that perform the best and start testing those, and then take your final design out and do the high explosive field event where everybody sees the fireball and you see the results from it. And we're very excited about that. We like to see the fireball too.
Absolutely. I want to see the fireball.
Yeah.
So it's all about data. Everything at ERDC is pretty much data driven.
Very much so. And all that data gets transitioned into how to predict the response of buildings or how to better retrofit those before the event happens. Also, you can do a little bit of forensic analysis if you've had something happen and you want to determine what load that was that created that kind of damage. We can determine that.
You can recreate what happened.
Yes.
Wow, that's so important. Why is it important for researchers and engineers to better understand the effects of explosive detonations?
Well, it can be a very complicated issue when you talk about different explosive sizes versus range. Each one has a unique pressure and impulse. And so the more we can understand it, or the better we can understand it, then the better the numerical models get, the better the designs get. And so ultimately, we may not be able to say that we can strengthen a wall to prevent failure, but we can strengthen a wall enough to mitigate the debris hazard that's going to be associated with it.
Right.
So to protect the people inside. We may not be able to save the building, but maybe we can save the individuals inside or the personnel that are there.
Right. So important. So important. So one major goal of ERDC research is to develop technologies that keep our men and women in uniform safe. How does the ABLS support that mission?
This allows us to do the traumatic brain injury experiments or hearing protection experiments or body armor for that instance. How does that affect your system when you're subjected to increasing pressures? And so what we can do is install multiple mannequins in the target vessel there and then instrument each one, put different types of protective equipment on them, and then see how the equipment and the pressure gauges on the mannequins or the different instrumentation that we have there, how it is affected by the increasing pressure. Also, we rotate whether they get hit from the front, the left, right, or rear. We'll turn the mannequin around and look at the different effects from which direction the blast wave may be coming.
Okay. Have you ever thought about teaching this, what you do?
Well, the original plan was to be here at ERDC for a few years and finish my PhD, which they helped me do, and then to transition into the university environment. But we wanted to build the advanced blast load simulator. It's been on in the plan for roughly 20 years.
Okay.
And so I kind of got redirected and looked at, I didn't necessarily want to leave before we got to the final the final project.
It was goals.
It was a goal, yes,
Right.
very much so.
Right.
And so now we have it here, but now I want to see how it functions, and I'm not ready to head out that door and go teach yet.
Right. But I can tell your excitement and what you do and your passion. And I say this all the time. I say this on the show all the time. People that sit in the chair you do, you can't teach passion. And you're very passionate about what you do.
Well, I appreciate that.
Absolutely. Absolutely. So aside from the military, who else can benefit from this technology?
Well, we have a lot of private industry that comes in to do research in this area, especially blast effects. It can also be transitioned into the fuel and gas situation. If you have an accidental explosion, how is that going to affect the neighborhood surrounding that particular facility, the buildings inside that facility also. Mm-hmm. So it gets transitioned into new glass retrofits for windows, things of that nature. There's a direct transition. The government has the capability to do a lot of research because they have the funding there. But ultimately, that can be transitioned into the private sector, into private industry also. And so it kind of provides a head start, so to speak, or to get going in that area, and then you kind of transition and let private sector, on occasion, take over and develop it further.
Right.
So
Okay.
there may be a situation in the future where you have a government facility that may be a high target for potential terrorist threat. Well, what do you do for the buildings that surround that area? How do you retrofit them? What's your building codes going to be? Are they going to be increased based upon threat levels for surrounding buildings?
Right.
How does that play into the construction of those private facilities? It could be a direct transition from what have we learned in the military and how to not necessarily harden, but strengthen those structures or retrofit something that's already there.
And it all connects.
Yes.
It all connects. So can the ABLS increase our understanding of blast effects on on infrastructure such as buildings, dams, bridges, etc.?
Yes. And you'll hear us, if you come on a tour for the blast load simulator, you'll hear me talk about walls, windows, doors, because that's what most people bring in.
Right.
But we also tell our customers that walk through, or potential customers, I'll say, that if you bring me something that'll fit in the hole of one of those target vessels, if you bring it in there, I'm going to shoot it for you. I'm not worried about if it's a window or a wall or a door. If it'll fit, we'll shoot it.
Because I'm trying to think I think it was a window when I went and witnessed what I did. It was a window,
Yes.
right? It was the effects of how the particles went everywhere.
Yes. So there is a damage level that we qualify different materials for, whether it be moderate, high, or deadly damage,
Right.
Catastrophic, I'll say.
Right, right.
We will categorize that based upon the damage that we find or the fragments or debris that we find in the target vessel there. And so there's a different American standard of test measurements that we have to go by. And
Sure, there's the acronym somewhere
yeah,
there.
there's an ASTM there, yes.
There you go. There's always an acronym everywhere. So you're probably one of the very few women who works in this field. How did you get interested in this work, and how do you feel knowing the difference your research makes?
Well, I have a very personal attachment to this. I had an uncle that was killed in Vietnam when his tank ran over an improvised explosive device. And so seeing the pain that my grandmother and my aunts and uncles
Right.
went through, and I was not alive when this happened to him, but knowing the residual effects that had occurred on them, I thought, man, how can you prevent this?
Right.
What way can we move forward? And so that's always kind of been in the back of my mind, even from the early college years, is how can I move forward in that direction? I got sidetracked there for a little while with Shell Oil Company, but I think ultimately this brought the best satisfaction as far as we don't always get to see the benefits of our research, but every once in a while we'll hear from somebody that something that we designed or ERDC designed, not necessarily anything that was done in the BLS, but something that ERDC did saved lives. And then that's a very fulfilling, I don't even know how to explain it, just that you could maybe let someone come home and return to their family. Something you did may have helped that.
That causes you to poke your chest out and say, it's just proud.
Yes.
And I noticed, I think Miss Pat Sullivan, she posted, she was somewhere and had her ERDC shirt on, and somebody approached her and said, because of what ERDC technology was developed, saved their life. So she was just kind of speechless because of that. So it just proves to show that what goes on at ERDC is just so amazing.
Yes, and ERDC has been on a couple of 60-minute specials dealing with 9/11 and what happened there and the attack on the Pentagon. And if you watch a couple of those specials, you'll see the blast load simulator in the footage there, where we were doing some experiments on wall retrofits and how to better protect the occupants inside. And we'll say that there was a retrofit that was applied. We'll call it version 1.0 because it was very a juvenile version of the retrofit versus what we have today. But we've heard very good stories about who survived because of that retrofit, the
Right.
procedures that were evaluated. And then we did a lot of post-tests to how better can we design this? Is there a better design for this particular material or construction technique? Or and sometimes we realize, hey, you just don't need to go in that type of building. If it's constructed using this material, that material, maybe you don't need to be there. Maybe you need to find a better, stronger
Right.
facility to be in.
So with the 60 Minutes episode, is there another way that people can see this?
Yes, we actually have been on another TV show.
Okay.
It was Penn and Teller Tell a Lie.
No way.
Yes, and so the premise behind this particular show is they have like 5 different stories, and 3 are true or 4 are true, and 1 is a lie. And so they came down and they did recorded some footage at the blast load simulator dealing with, again, wall retrofits, because that's what was the hot topic at that time, I'll say. And so it was very interesting to see how they took what we do on a daily basis and turn it into it.
Did they make it the truth, or did they make it a lie?
Oh, we were the truth.
Okay,
yes.
okay. I didn't know if they were telling a fib about what goes on at ERDC. So we had Dr. Malarker a few weeks ago. We did the first show, and he talked about 9/11 and the impacts of ERDC's research and how important it was for that. So,
yes, I always when September 11th rolls around and they start doing the replays of the different 60 Minutes shows and on the History Channel, I always kind of tune in.
Right.
It just kind of reminds you of what is done right here in Vicksburg, Mississippi.
right, absolutely. So, what would you like listeners to learn from this valuable conversation?
Again, what's going on in Vicksburg, Mississippi? It's a small town compared to these larger facilities that are everywhere else, and you never know what's going on at your neighboring towns or cities and what each person is capable of. I never thought growing up that I would be running the blast load simulator. Now, I did build a lot of tree houses and tore them down and rebuilt them a lot growing up. That was always kind of my thing. But,
Right.
And keep your mind open. Again, I did not really understand what ERDC was when I graduated from college, but I saw the opportunity there and made that transition. So don't be afraid to transition into something that's not your normal civil engineering job.
Right.
Because you never know what you're going to miss out on.
Well, thank you so much for what you do to make a difference in not only our communities, but our nation. And it's amazing. Thank you.
The U.S. Army Engineer Research and Development Center, or ERDC, is the premier research and development center for the U.S. Army Corps of Engineers. Hello, I'm Carol Coleman, and I would like to share with you how ERDC makes the difference. Established in 1998, the ERDC is home to more than $1 billion worth of world-class facilities located in 7 laboratories and multiple field sites across the country. The organization's main campus is situated on the historic Waterways Experiment Station in Vicksburg, Mississippi, and consists of the Coastal and Hydraulics Laboratory, the Environmental Laboratory, the Geotechnical and Structures Laboratory, and the Information Technology Laboratory. ERDC also operates 3 laboratories not located on the West Campus, including the Construction Engineering Research Laboratory in Champaign, Illinois, the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire, and the Geospatial Research Laboratory in Alexandria, Virginia. Each laboratory has their own unique mission and operates as integrated teams of engineers and scientists to address a broad range of science and technology issues. The Coastal and Hydraulics Laboratory, or CHL, addresses an entire spectrum of water resource challenges. Their mission is to deliver solutions to our nation's most challenging coastal and hydraulics problems. As part of the CHL, the Field Research Facility, or FRF, is a U.S. Army Corps of Engineers field site located in Duck, North Carolina. The cornerstone of the FRF's contribution to coastal research has been its long-term data measurements that stretch back to 1977. The long-term measurements have made the property one of the best studied beaches in the world. Providing solutions for tomorrow's environmental challenges, the Environmental Laboratory, or EL, is ERDC's primary center for ecosystem science, ecosystem technology, and environmental resiliency research. The laboratory is home to the Aquatic and Wetlands Ecosystem Research and Development Center and the Hazardous Waste Research Center. ERDC's Geotechnical and Structures Laboratory, or GSL, supports our nation's defense, security, public safety, and infrastructure. GSL is home to the world's largest heavy vehicle simulator, the Centrifuge Research Facility, and the Advanced Blast Load Simulator. In today's fast-paced digital environment, the Information Technology Laboratory, or ITL, provides innovative solutions to solve the nation's most complex and challenging IT and computational issues. The laboratory's Supercomputing Resource Center is one of only 5 Department of Defense computing centers operated by the DoD High Performance Computing Modernization Program. For more than 50 years, ERDC's Construction Engineering Research Laboratory, or CERL, has supported the Army's ability to design, build, operate, and maintain its installations and contingency bases. Located in Champaign, Illinois, the laboratory is home to the Triaxial Earthquake and Shock Simulator. ERDC's Cold Regions Research and Engineering Laboratory, or CREL, delivers environmentally relevant and transformative engineering solutions to test, evaluate, and improve infrastructure and equipment, particularly for use in cold regions. Located in Hanover, New Hampshire, the laboratory is home to the Frost Effects Research Facility, the largest refrigerated warehouse in the United States. The Permafrost Tunnel Research Facility is a U.S. Army Corps of Engineers field site operated and maintained by ERDC's CREL. The tunnel, located just outside Fairbanks, Alaska, is a unique natural research facility with features up to 40,000 years old. ERDC's Geospatial Research Laboratory, or GRL, located in Alexandria, Virginia, serves as the Geospatial Research and Development Laboratory of the U.S. Army Corps of Engineers. GRL is the only dedicated geospatial research and development laboratory in the entire Department of Defense. As the premier research and development center for the U.S. Army Corps of Engineers, ERDC has unique, world-class equipment and facilities. To learn more how ERDC discovers, develops, and delivers innovative solutions to the nation's toughest challenges, be sure to listen to Beyond the Gates on News Talk FM 107.7 on Thursdays at 8:15 a.m. and 9:10 a.m. or check out past shows on vicksburgradio.com. We discuss exciting research with representatives from one of the 7 ERDC laboratories, and they describe how their projects are important to the community, the region, and the nation. Again, I'm Carol Coleman with ERDC. Thanks for listening.
The U.S. Engineer Research Development Center, or ERDC, is the premier research development center for the U.S. Army Corps of Engineers. Hello, I am Jared Eastman, and I would like to talk to you about how ERDC contributed in the Second World War. America's entry into World War II had a dramatic impact on the Corps of Engineers and the Waterways Experiment Station, which would later become ERDC. WES quickly changed its focus from civil works to military projects. Changing priorities, transfers, and call-ups for military service profoundly influenced the station's operations. WES personnel focused their efforts on building training facilities for the Army, harbor and channel improvements for the Navy, and revolutionized airfield construction to support the Army Air Corps. Model studies, the hallmark of WES, were made of selected landing sites in North Africa, Italy, and France. Models were also made to the benefit of Allied bombing crews, such as the V-1 and V-2 rocket launch pads and the German ball bearing works in Schweinfurt. Research that happens at WES was crucial to the success of military operations around the globe. Research that happened at WES was crucial to the success of military operations around the globe. In their drive to liberate Western Europe and invade Nazi Germany, Allied forces had to cross numerous rivers that posed formidable technical difficulties. As it was anticipated that no permanent bridges would be left standing, crossings were to be made on pontoon or pneumatic float bridges. Although American pontoons could carry heavier loads in low-velocity flows than their British counterparts, they performed poorly in heavy-velocity flows, like those that would be encountered in Europe. In their drive to liberate Western Europe and invade Nazi Germany, Allied forces had to cross numerous rivers that posed formidable technical difficulties. As it was anticipated that no permanent bridges would be left standing, crossings were to be made on pontoon or pneumatic float bridges. Although American pontoons could carry heavier loads in low-velocity flows than their British counterparts, they performed poorly in high-velocity flows, like those that would be encountered in Europe. West personnel worked around the clock, 7 days a week, from June until November 1943, to develop and test various designs that would reduce skin friction between the pontoons and water and prevent overtopping of the bow or sides. On the night of March 23, 1945, companies from the 17th Armored Engineer Battalion utilized the new design to construct treadway rafts to prepare the crossing of the Rhine River south of Wessel. Bridge construction started at 9:45 in the morning, and by 4 p.m., the first truck crossed into Germany. The bridge, comprised of over 1,152 feet of M2 treadway and 93 pneumatic floats, was completed in just 6 hours and 15 minutes. Air power was a decisive factor in Allied victory in World War II, both in Europe and in the Pacific. Yet, as late as 1939, most runways, taxiways, and aprons were either sod fields or rigid pavement that could not withstand the anticipated traffic levels and stresses produced by heavy military airplanes being developed. To address this crisis in airfield design, engineers and scientists looked to asphalt-based surfaces to accommodate heavy bombers of the time, such as the B-32 Dominator and the B-17 Flying Fortress, some of which could weigh in excess of 120,000 pounds. West quickly emerged as a world leader in flexible pavement research, as well as the development of expedient surfaces such as landing mats for rapid construction of temporary or emergency airfields in combat zones. The revolutionary developments in airfield design produced at West were key to gaining air superiority and would become the standard for commercial airfields. To learn more about how ERDC discovers, develops, and delivers innovative solutions to the nation's toughest challenges today, be sure to listen to Beyond the Gates on News Talk FM 107.7. Thursdays at 8:15 a.m. and 9:10 a.m. Or check out our past shows on vicksburgradio.com. We discuss exciting research with representatives from one of the 7 ERDC labs, and they explain how their projects are important to the community, the region, and the nation. Again, I am Jared Eastman, ERDC Public Affairs, and thanks for listening.
The U.S. Army Engineer Research and Development Center, known to most as ERDC, is the premier research and development center for the U.S. Army Corps of Engineers. Hello, I'm Mary Miller Morgan, and I would like to talk to you about how ERDC is making a difference through the Engineering with Nature initiative. The U.S. Army Corps of Engineers, also referred to as USACE, introduced the Engineering with Nature initiative in 2010 with the goal of aligning engineering processes and natural systems in order to efficiently and sustainably deliver economic, environmental, and social benefits. Engineering with Nature provides a means for delivering nature-based solutions across USACE missions such as navigation infrastructure, flood risk management, and ecosystem restoration, which involves reducing ongoing infrastructure maintenance costs by millions of dollars each year and enhancing local economies by increasing wildlife habitat and providing recreational, cultural, or educational opportunities. ERDC has partnered with Engineering with Nature on many projects to deliver nature-based solutions across the globe. One of those projects is the Tyndall Coastal Resilience Study Project, where researchers aim to reduce coastal flood risk by building or enhancing natural habitats such as beaches, marshes, or dunes to reduce wave and water levels on the installation. Another research project focuses on optimizing nature-based solutions for cold regions. Point Hope, a village in remote northwestern Alaska, is experiencing coastal erosion, flooding, thawing permafrost, and sea level rise. To address these impacts, ERDC and partners are working to incorporate natural and nature-based features to help mitigate flooding and erosion in order to protect the cultural heritage, food security, and safety of the indigenous community. To further integrate nature-based solutions across USACE, Engineering with Nature established proving grounds where 6 USACE districts and 2 divisions are integrating nature-based solutions into full-scale infrastructure projects, testing innovative methods, and documenting lessons learned. Through these projects, USACE partners are managing flood risk, restoring aquatic ecosystems, and developing navigation infrastructure while adapting to new conditions under climate change. Through Engineering with Nature, ERDC is delivering innovative solutions that are sustainable, economically viable, environmentally impactful, and collectively equitable for the American people. To learn more about Engineering with Nature, please visit engineeringwithnature.org. ERDC continues to make a difference through our research and development efforts. To hear more about what we do, please be sure to listen to Beyond the Gates on News Talk FM 107.7 on Thursdays at 8:15 a.m. and 9:10 a.m. or check out past shows on thevicksburgradio.com. We discuss exciting research with representatives from our 7 laboratories and how their projects are important to the community, the region, and the world. Again, I'm Mary Miller Morgan with ERDC, and I thank you for listening.